Well, good afternoon and welcome back. I recognize a couple of the names here who've joined us at the previous presentations. My name's Peter, and I'm more than happy to welcome you to our third presenter of the day, Keri Bean. Keri Bean, she's got kind of a cool job, and her background is super nifty, and I'll let her explain all of those details to you. Um, but on behalf of the Maker Faire Milwaukee and Gearbox Labs, we're super excited to have you here. Um, Keri is a systems engineer at Jet Propulsion Laboratory out in Pasadena, California, where I'm sure it's a lot warmer and sunnier than it is here in Wisconsin. Couple things to note. The Slido app on the right side of your screen is where you can enter your questions. Um, and we'll get to the questions at the end. You can also turn off your video if you need to, because we are recording this. So Keri has got this super interesting background, and she's doing a lot of work on Mars right now. And again, I'm not going to steal her thunder, but the stuff you do on Mars is uber cool. And with that, I will let you take it away. And thank you, Keri, for presenting today and sharing your inspirational experience. Thank you.
Yeah, thank you for having me. So I'll talk a little bit about my career at NASA here, along with some of the hobbies I'm into. You may notice some familiar faces behind me with R2D2 and C3PO. I might be a little obsessed with Star Wars, and we'll get into some more details about that later. No, oh, please click. There we go. All right. I'm a systems engineer at NASA's Jet Propulsion Laboratory in Pasadena, California. Currently, I work on the Curiosity Mars rover and the Ingenuity Mars helicopter. I've worked on quite a lot of NASA missions at this point, including the Mars exploration rover Spirit and Opportunity. I worked on the Dawn mission when it was at the Dwarf Planet Ceres in the main asteroid belt, and a lot more. And as said, I also love Star Wars. The picture here is from the day that BB-8 came to visit JPL and film a couple videos for Disney. And I was really thrilled and got to meet BB-8 and hang out with BB-8 most of the day. And that was definitely one of the top highlights of my career at JPL for sure. So what I do at NASA. So for Curiosity, I'm the deputy lead rover planner. So the rover planner is also better known as a Mars rover driver, and we also operate the robotic arm for Curiosity as well. So been learning how to be a Mars rover driver for a very long time. It usually takes 2 to 3 years before you get your driver's license. And then I've been able to climb. Oh, Misty. Sorry, cats are also going to come join us in the presentation. I can't control them. Um, I've got my driver's license. I got it a couple years ago. And I also now am the deputy lead. So I'm responsible for training all the new Mars rover drivers. I'm also dealing with documentation and interfacing with other teams and all the sorts of leadership stuff that comes with that. It's been really exciting to work my way up to that position. And my other job at JPL is called Helicopter Integration Engineer for Mars 2020, which is the combination of Perseverance and Ingenuity. So part of my role is that I'm kind of the interface between the rover and helicopter teams. So there's the helicopter team. They're the ones that actually command the flying, figure out where we're flying, and all that sort of stuff. But my part of my team is we actually work with the rover team of okay, if we want to take a video of Ingenuity flying, when are we going to fly? How are we going to point the cameras to make sure that we take good video? Is the helicopter going to be safe? We do terrain assessments of where we're flying and say, oh, maybe we should tweak the path a little bit because there's going to be some particularly scary rocks that we're going to fly over or something like that. So a lot of that interface and negotiating is what I do with the helicopter. So for my educational background, I have moved a lot. My dad was a military contractor, so I never stayed in any one place for more than a couple years. And so I went to school in Texas, South Carolina, and Virginia. I also was homeschooled for the 5th grade as well. I finally ended up in Texas for university, where I got my bachelor's in meteorology and I got minors in math and earth science as well. And then I stayed at Texas A&M to get my master's in atmospheric science. Now, most people, when you think of meteorology, you think of TV weather forecasters or the hurricane hunters or the tornado chasers, all those kinds of folks. But I actually spent my time studying Martian meteorology. So Mars has a bit of an atmosphere. It's not much, it's about 8% of Earth's. So to give you an idea, normal surface pressure is what we call 1,000 hectopascals. The very top of Mount Everest averages around 300. Mars' surface is 8. So it's a very small amount of the atmosphere. But it's enough that we have weather. We have clouds, we have dust devils, we have a lot more. So it's been really fun to actually study the weather on Mars. So growing up, I didn't really know you could study the weather on Mars, but I was always interested in weather. So I kind of changed my mind of what I wanted to do quite a bit. I had some interest in space. It wasn't like my main interest, but when we lived in Texas, we would visit Johnson Space Center in Houston. And, you know, I got to experience a lot of different meteorology things. Since my dad was an Air Force contractor, I got to meet some Air Force meteorologists of what that was like. The middle picture you see there was from one of the local meteorologists in San Antonio, where he had me come over for a day and I got to shadow what it was like to be a broadcast meteorologist. And when I really started getting into space was my family was doing the whole Disney World vacation while I was in high school. And it just so happened to be the week of a space shuttle launch. So we all piled into the car. We went to go see the space shuttle launch. It was STS-114, which was the return to flight after the Columbia disaster. And you can barely see it, so I have it in the little oval shape there, but it was a lot more clear in person. You could definitely still hear it, even though we were very far away. And that's when I really started getting interested in space. So the next thing I did, since I was getting this interest in space, is I went to space camp in Huntsville, Alabama in 2006 and 2007. And I got to learn all about space. It was a really exciting experience and it was totally worth it. I got to meet lots of cool people. And in fact, some of the people I went to space camp with, I work with on the Mars rovers. So it was really cool to get to meet people that have similar interests and are still friends, you know, more than a decade later now. So I graduated high school on May 25th, 2007. So it's a picture of me and my family there. And then when I started at Texas A&M, I met a professor, Dr. Mark Lemon, and he said, hey, you know, if you're interested in these Mars rovers, that's what I do. I study the weather on Mars. Why don't you come work with me? So I immediately started working with him on Spirit and Opportunity. And my very first summer of college was when the Phoenix Mars lander landed on Mars, kind of near the North Pole. And he was in charge of the main camera on the lander. And so he was like, hey, do you want to come be my student assistant for the summer? So exactly 1 year to the day from when I graduated high school, I was in mission control and I was the person putting the images up on the screen as they were coming down from Mars. So that was quite a year journey going from high school to in Mars rover landing mission control. Um, so that was quite an experience and I totally got hooked to working on these Mars missions. And so Mark Lemon kept me involved in all of these missions. So I worked on Spirit and Opportunity. And then when the Curiosity rover came along, I started working on it about a year before launch, also a part of the camera teams and the meteorology team as well. And so I ended up working on Mars time for this rover along with Phoenix. So a Mars day is about 40 minutes longer than an Earth day. So imagine that you go to work one day and it starts at 8 a.m. The next day it starts at 8:40 a.m. The next day it starts at 9:20 a.m. And it goes all the way around the clock until you're starting at 1 a.m. or ending at 5 a.m. or things like that. It's quite an interesting journey to live on Mars time. I've now done it 3 times because I did it for Ingenuity as well. So you know, we get to be Martians for a while. It's pretty cool. But when I was working on Curiosity, that's when I really got interested in staying and working on these missions. And so luckily, since I was working at JPL as a student at that time, I was able to get in touch with some folks who ended up being able to hire me to work at JPL full-time on the Dawn mission is what I started out on. But while I was in college, I did have some fun being a meteorology major. So for a while, I was actually the lead forecaster for a storm chasing club. So this is just some of my favorite pictures from my storm chasing adventures. So did see quite a few tornadoes. The bottom picture there was actually with one of the tornado intercept vehicles that we happened to see while waiting for the storms to brew up. It was a lot of fun. You know, don't do it without proper training, and we were never the crazy folks you see on TV. Our general rule of thumb was if you have to crane your neck up to see all of the storm, then you're too close. So you know, we've stayed a lot more safe than the folks show on TV, but it was still really exciting to be a part of that. So here's a little more about the Phoenix Mars lander. So the picture on the left shows me in our test bed. So whenever we work on a mission, you know, we build the real one that goes to Mars, but we always build a lower end copy that we keep here on Earth. And that's because if we're doing something unique and hard, we want to be able to test it here on Earth because it's a lot easier to fix the machine here on Earth than it is on Mars. So for some missions, this what we call a test bed could be just a rack of computers. That's what it was for Dawn. Can't really have a space flying orbiter in a room. Whereas like the Mars rovers and landers, we have actual physical copies of, and that's to full scale. So it's been really fun getting to learn to work with test beds. I find it a really enjoyable experience because it's really a puzzle of will this work, will it not? If it didn't work, how do you figure out how to make it work? All that kind of stuff. It's a really fun technical problem when you're working with test beds. And then the photo on the right there, that was from landing night. So I circled myself because it's a little hard to see there. But that was landing night, and you could see all the scientists poring over the images as I'm putting them up on the screen from the very first time that we've seen pictures with this spacecraft on Mars. So it was a really rewarding experience. So one of the missions I worked on for a really long time was the Mars exploration rovers. And
you guys have heard of the Mars exploration rover, right?
Oh, I'm hearing an echo. Thanks. So I worked on the Mars exploration rovers since 2007 through Opportunity End of Mission in 2019. So it was a really large part of my life. I started out on the camera team and the meteorology team. And then when I got to JPL, after I worked on the Dawn mission, I went straight back to Opportunity and worked my way up. And by the end, I was doing just about every role that you can do on the rover. Including at that time, I was training to be one of the Mars rover drivers when we lost contact. Unfortunately, being a meteorology major, I had made all sorts of jokes about how I was going to be a rover driver and turn it into a storm chaser and go after the dust devils. You can see examples of the dust devils at the top there. Unfortunately, we had a global dust storm, and as you can imagine, a global dust storm would block out the sun, and for a solar-powered rover, that's not really good. So unfortunately, we lost contact and never regained it. But it was a huge part of my life. I've worked on the rover for about a third of my life so far, so it had a really big impact on me. And I still miss working with that team, even though I still work with them a lot on the other rovers. It was a really special project. There we go. So the other rover, this is one of the ones I currently work on, of course, is Curiosity. Much bigger rover, nuclear powered, not solar powered. So this one's still going, even though it also went through that same global dust storm. And I started out on their meteorology team and the camera team. So the photo kind of in the bottom right there shows me on Mars time with a whole bunch of the other scientists in the room. This sure was probably taken in the middle of the night. And we were planning out what we were going to do on Mars. And then today, I'm working as one of the rover drivers, and hopefully soon I'll start working on some of the other roles as well. So Ingenuity is our very first attempt at flying on another planet, and it has worked spectacularly. We just finished our 13th flight. We only had 5 planned, so of course going past what we expect. The really interesting thing about Ingenuity is it's a technology demonstration. We had no idea if it was going to work. We had some reasonable idea of what it would take. You know, certainly did our research and testing, but there's only so much we can test. We can't change the gravity here. We could try and offset it using like a system of levers and pulleys to help offset the weight. We have a vacuum chamber, so we put it down to the Mars pressure that I talked about, how it's much thinner. But we never really knew until we went to Mars. And so it's been really fun to be a part of something this historic. And it's still something I'm still kind of in shock that I got to do. Another, you know, I got to be in mission control as the data was coming down, and finding out was just a really special experience. So it's been really fun. It's really cool, and I hope it continues for quite a while. So now I'll talk a little about my side hobbies. So you can probably see R2 and C3PO behind me here. So I had taken a shop class when I was in middle school, so I was a little interested in doing more like hands-on work. And then I found out there was a club of people who actually built their own R2D2s. And at that point, I knew I had to have my own. So I figured out how to do it. The club has some really great resources. It took about 2 years, and I built my own. So the C3PO was actually built by my boyfriend, and he actually wears it as a costume. And so it's always a real big hit when we go out together between R2 and C3PO. Everyone kind of loses their mind and wants photos. So the photo there you can see of R2 and C3PO, and I'm dressed up as Rey. That was actually taken at JPL at one of our Halloween costume contests that we have. Unfortunately, we didn't win, which I'm very sad about still, but you know, it was still very appreciated, and a lot of people enjoyed taking photos with us. So I wanted to show just a couple photos of what it was like building R2. So this is just some progress photos I took along the way. I ended up having a sort of baby shower for R2. So that's what one of the pictures is there, of all the parts labeled for all the friends who aren't building R2, so they could figure out, oh, this is what this is called, and here's how it goes. And it was really fun to see, like, as I was getting parts and making parts, just slowly how it would come together. And the more you build it up, I still had to do all the painting, sanding, attaching parts, all that kind of stuff. And so finally got all the way to this finished product over here. You know, he's still in work. One of the things I'm currently working on is all these little panels, especially like up on his head. I want them to be able to open. So I've got servos and everything installed. I just need to actually get around to doing the wiring for it. You know, make him more animated. Next would be like getting these arms to be able to pop out. And these are just 3D printed arms. Most of him's in aluminum, but you know, occasional little 3D printed parts and that sort of thing in there that I was able to do. Another thing that I do is I cosplay with the Rebel Legion. This is a group that cosplays as Star Wars characters. The Rebel Legion is focused on the good guys, so the Jedi and that sort of thing. There's a counterpart called the 501st, and they're the ones who cosplay the bad guys, the Stormtroopers, Darth Vader, all that kind of stuff. But obviously we're close sister organizations and do a lot together, and most people are members of both with the costumes they have. It's a really fun organization. You know, we get to do a lot of fun events. So we call them troops. So you get to dress up in character and get to go into a lot of cool places. So some of these pictures are from Legoland when they had their Star Wars days. We've been to like Air Force, you know, shows. So you can see kind of the planes with the clone troopers and me as Rey there. Photo on the bottom left is from one of the air shows. That's the Blue Angels in the background. And you know, sometimes I bring R2 with me as well. So it's pretty fun to get to dress up, be in character, and get to interact with the public, pretending you are that character. I also do other cosplays as well. Some of these I've partially built. Some of these I just bought online. But you can see I've got some Doctor Who, Captain Marvel, Harry Potter. I actually went on a 2-week trip to England with my Harry Potter costume, just going to filming locations and taking photos. That was a pretty fun trip. And you know, just a lot of nerdy dressing up in general. The other thing I like to do is when I go to like Comic-Cons and that sort of thing, I really like to incorporate Star Wars into outreach. You know, a lot of people are familiar with Star Wars, but they may not be as familiar with some of our NASA missions. So in particular, when I was working on Dawn, it was an ion engine mission. Well, TIE Fighter stands for twin ion engine. And so I was able to make a lot of comparisons about Dawn and TIE Fighters. And so you can see I've got a slide comparing them that I would use in my talks. And when I talk about Mars, I make a lot of parallels to Tatooine and that sort of thing. So that's something I also really enjoy when I get to talk to the public. And with that, I believe that is my last slide. So I will be happy to take questions at this point.
Keri, thank you for sharing that with us. You've got this kind of amazing, eclectic experience, both in your professional and personal life. It's a lot of fun. It looks, I mean, you're beaming, having way too much fun for it. We are going to transition now for everyone who is watching. We have the Q&A open. We've promoted one of the first questions coming in. First question came in. Is the R2D2 remote controlled? Does it move? What's going on with R2D2 in terms of how you're making it move right now?
Yeah, so R2D2 is remote controlled. I have 2 custom controllers that one of the builders in the community makes what he calls stealth controllers. So that's what I use. They're really tiny, so you can hide them in your hand, which is really fun to see kids like trying to look around like, who's controlling R2? But they can't tell because the remotes are so small, they're just hidden in your hand. And one of them controls how I drive him. So, forward, back, turn, all that kind of stuff. The other one controls the head motion. So his head can spin in different directions. And then there's a series of buttons that I can push for him to make special sounds. Once I get the panels and everything wired up, some of those buttons will trigger the panels to open and that sort of thing. So yeah, he's definitely remote controlled.
I have actually a question. I've seen the pictures of Ingenuity on Mars, and you had a picture there. You actually never saw Ingenuity in front of a person or something to kind of scale it. It's actually kind of tiny. I went, oh, he's kind of like I mean, not a toy, but it's tiny. I'm really curious as to, other than the flying around, you're testing, its command and control and that. What else are you looking to learn? Or what's the team at JPL looking to learn about this test concept of flying on Mars?
Yeah, so in Ingenuity's extended mission here, because we only planned for about a month of operations where we're just learning, can we fly on Mars? Can we control the direction we're flying? How high can we go? That sort of thing. We've now transitioned into this really cool, okay, so now we've learned we can fly. How can we use it to help future missions? So we're actually more of a companion to the Perseverance rover now. And a lot of what we've been doing is actually doing scouting flights. So using our color imager to scout the path ahead for the rover. They want to drive the rover into this really, not necessarily dangerous, but tricky area to drive through. And so they're actually using Ingenuity to scout how would the rover be able to safely go through that area in advance while the rover is collecting its very first samples on Mars. So this will be something the rover is going to do over the next couple weeks. And so I just think that's really cool that we've transitioned our whole mission now of we just want to figure out if we can fly to, all right, we know how to fly now. Let's figure out what we can use this technology for. So it's been really fun to, yeah.
Part of the team. Super. Thank you for answering the question. Isabel asks a question about what kinds of materials are you using to build the Mars vehicles, really multiple vehicles. What kinds of materials does NASA use?
Yeah, it's a great question. So a lot of titanium and other really durable metals. We have to be really careful because we're going into space and certain metals can actually warp in the vacuum or in the extreme heat and cold of space. They have a lot of things that can affect it being in space and the radiation and that sort of thing. So a lot of testing is done to figure out what materials are safe to build all of these rovers out of. And technology is getting better all the time. Metal alloys are being developed that are even better and stronger. So a lot of titanium, but some other materials possibly in the future.
Super, super. Hayden asks the question, back to R2D2, what gave you the inspiration to build R2D2?
Oh, that's a good question. So I ended up getting inspired to build R2 through social media, sort of. So um, I like to share a lot of what I do on these Mars rover missions by tweeting it, posting on Facebook, Instagram, that sort of thing, because I know a lot of people are really interested, and especially in like the personal perspective of what it's like to work on these missions. So I post a lot about that. And someone reached out to me of like, hey, would it be possible for me and my R2D2 to come toward JPL? And I was like, what do you mean your R2D2? I had no idea there was this builders club. And so he like showed me pictures and that sort of thing. I was like, yeah, sure. Let me figure it out. I had no idea if I could allow R2D2 to come to JPL. I had to go read the rule book of like what's allowed. No weapons. Okay, he doesn't have his taser. Let's figure it out. So I ended up inviting the person to come right around Halloween many years ago. I want to say this was like 2014. Um, and then I had invited him, but then he was in the San Francisco Bay Area, and I actually got invited to attend an event in the San Francisco area called Science Hack Day as an ambassador talking about NASA missions and how people can use data from NASA missions in cool ways. And so he brought his R2D2 to the event, and as soon as I saw that R2D2, I was like, I know I have to have my own. And I was like, okay, I'll wait until, I was living in a tiny apartment in Hollywood at the time. So I was like, okay, I'll wait. Until I have a good place to work on it, that sort of thing. And then I attended in 2015, there was an event called Star Wars Celebration. It was a very big convention by Lucasfilm celebrating Star Wars by Disneyland. And I went to that, and there was a whole builder's room there. There was, I want to say, like 120 R2D2s.
Wow.
Not all of them were R2D2. People also do custom colors. There was like a steampunk themed one, like all sorts of stuff. And, this was before Force Awakens, but people knew about BB-8. So people were trying to figure out how to build BB-8 at that time. So there's a couple prototype builds there. And just when you walk into a room and there's like 120 R2D2s beeping and booping at you, I just like lost it. I was like, okay, I have to start now. And I literally went home and ordered my first part that night. So started in April 2015, and I finished in May of 2017. So
Oh, wow. Wow.
about a year and a half of that was just collecting the parts, figuring out what I wanted to do, and then about 6 months of like nose to the wall, just build.
Super. We have a question. We're going to kind of go back to Mars for a second. How many rovers, how many vehicles are on Mars right now?
Yeah, so that's a good question. So for spacecraft that are active on Mars right now, so we have the Curiosity Mars rover, which went in 2012. Then we have the Perseverance rover, and of course Ingenuity, which landed earlier this year. We have the InSight lander, which landed back in 2018. And then China also has a rover that's active on the surface. And I believe that's all the ones active on the surface that I can think of. Now, there are several spacecraft that are in orbit around Mars. They take weather data, they take pictures of the interesting geology on the surface. They're looking at the atmosphere of Mars, learning how Mars atmosphere is interacting with space and the solar wind. So there's quite a few spacecraft there. I know I would forget some if I started naming them all off, but there's quite a few. And we use some of them actually to communicate with our Mars rovers. So we don't joystick our rovers, we don't command them in real time, they're too far away. So we'll actually generate 1 to 3 days worth of activities at a time and send them to the rovers. And once the rovers have collected all of their data, they send it to the Mars orbiters, who then send the data back to Earth for us, because they have much bigger antennas, much more power, being solar powered and above the atmosphere, so they don't have to worry about dust, and much higher data rates sending back to Earth. So we hear from the rovers probably like 4 to 6 times a day, getting all that info back.
Yeah, when we first met and we were starting to talk about your work, that's what amazed us, was the fact that you're right. This is not real-time communication. This is not like your joystick right in front of you commanding something. The amount of planning that you have to do. Can you talk a little bit about the team that you work with and the planning sessions that you go into? Because I think that's helpful. A lot of students think about they're by themselves, they take their test, they do their project all by themselves, and suddenly, boom, you're on a team. What's your teamwork like?
Yeah, so that's one of the things that really interested me in working in Mars rover operations versus like going on to get a PhD in academic study was working on a team. I really love that social environment and that collaboration. So the teams at JPL, they're hundreds of people. So for example, for the Mars rover drivers on both missions, there is not one Mars rover driver on shift. There's a minimum of 3. Um, so you have one person that's developing most of the plan for the day and writing the commands. And then you have one person whose main job is to check the work of the other one. You know, being a rover driver takes so long to get that background knowledge, 2 to 3 years, that we're the only ones really qualified to check the work. And then usually the third person, especially now that we're working from home, I'm driving the Mars rover from home. We have one person dedicated to communication channels, making sure we're keeping the science team in the loop of where we're driving to, you know, communicating with the rest of the team. Beyond that, we have what's called uplink leads. So they're kind of the ones in charge of the flow for the day, making sure that they're keeping the rover safe, that we're not using too much power, that we're sending back the data that we need to help the next plan. And then we have folks that operate every single instrument. There's different people that operate every single instrument, and each rover has like a dozen instruments. So there's a person in charge of the black and white cameras on Curiosity. There's a person in charge of the color cameras on Curiosity. There's one for, we have a whole bunch of different instruments on the end of our arm. So there's one for each of those. So it's a lot of different people there. There's also science team members. So I started out on the meteorology team. So I would make a request of like, hey, can we look at this time of day in this direction for dust devils? Or can we look for clouds at this time of day? That sort of thing. And then there's a set of geologists that are doing the same thing of they're looking at the pictures from the day before saying, oh, this rock is really cool. Can we get better observations with it, either with a robotic arm or using different filters on our cameras, that sort of thing. Then there's also a whole side for what we call downlink. So all the data that comes back from Mars, it's not just the pictures and the spectroscopy from the instruments. It's also all the health of the rover. You know, is power okay? Is thermal okay? You know, it didn't get too cold, it didn't get too hot, that sort of thing. So there's a whole bunch of engineers that also look at that data every single day. And then they also have representatives on the on that uplink team of, you know, any engineering maintenance or anything that needs to be done with the rover. And then on top of that, there's a whole strategic process. So, you know, what we call tactical, and uplink does that day's plan. But okay, what are we going to do over the next few days? Are we going to keep driving? Do we want to go to a spot where we're going to drill a sample to put inside some of the instruments on Curiosity? Or in the case of Perseverance, cache a sample, which they just did twice in the past week, that could potentially come back to Earth someday. You know, all those different things. So it's like hundreds of people every day, which is really exciting to work with such a like unique team. Yeah.
Wow. Wow. Well, it leads to one of the next questions that just popped out. I'll put it here in the live section here. Are these rovers ever going to come back to Earth once they finish their mission, or do they stay?
So that's a good question. So with Perseverance, we're actually collecting samples. And so the idea is that the next mission we're working on will actually go and collect those samples and bring them back to Earth. Now, as for the rovers and everything themselves, you know, Spirit, Opportunity, Curiosity, they're staying on Mars. Their mission was sent to Mars. They were designed for Mars. That's where they should stay. I personally think once humans finally get to Mars, we should turn them into like national parks. So, you know, Opportunity drove over a marathon's distance on Mars. So we should make like a walking path that you can like walk along the whole path of Opportunity and see Opportunity preserved at the end in her very final position. You know, same thing for Spirit. So that would be my personal ideal situation is turn them into national parks on Mars.
It's super. Okay, we have a couple questions about R2D2 again. One of the next question is about the 3D printer that you're using for R2. How big is it? What are you printing with it?
Yeah, so actually I used Shapeways to do all of my 3D printing for me. The only thing that I used a 3D printer for is initially getting holders to hold these sets of lights in. And I found out that just the electronics were running so hot, they're just kind of warping the plastic. So I eventually had to upgrade them to metal. Yeah, I use Shapeways. So whatever they're using, I don't know.
All right, one more R2 question here, more self-serving than anything else. And thank you, whoever asked it.
Also, here's Pinto. He's decided it's his turn to say hi.
There you go. Look at that. You're part of the crew here. You have to come to Milwaukee for the Maker Faire at some point in the future and share your R2D2 with us. So hopefully you can travel with R2. I don't know you ship them on a plane or how we get them here, but you've not been in Milwaukee yet, I'm assuming.
No, I have not. But I purposely bought a car to transport R2. I upgraded my car, and my license plate is R2D2 Mom. So, I can drive anywhere with them.
Super. Well, you'll have to come. You'll have to be here. Back to your NASA work. What kind of subjects here? I should promote the question here. So Isabel asked the question about what kind of subjects should students pay attention to in high school or school in general? I mean, grade school, middle school, high school.
Yeah.
What kind of subjects should they pay attention to?
So the good thing about NASA is that, most people think of NASA, they think of the rocket scientist, right? So of course, math, engineering, that kind of, science, STEM fields. But NASA isn't just rocket scientists. We have lawyers. We have just like it's a whole field. Like we have artists that design all of the mission patches and that sort of thing. So it's not, you don't have to just be, sciencey math person. Um, I know some people, in fact, I'll tell you the guy who's currently in charge of the black and white cameras on Curiosity, his degree is in multimedia design from the 90s, which he described politely as making CD-ROM menus. So, and now he's in charge of the cameras on Curiosity. So, you know, that's one of the things I've really liked about JPL is that, you can come from all these different diverse backgrounds and still end up doing something, contributing to the space program. I had a boss who used to have a degree, or she has a degree in biomedical engineering, and she worked in prosthetics. Now she works with robotic arms on spacecraft.
Okay.
So, you don't necessarily have to pick, oh, I have to be an aerospace engineer, or I have to do a physics major. Of course, you're going to have an easier time getting into NASA if you do those degrees, of course, but it's not a one set path. I have a meteorology degree. I do not have any sort of robotics background beyond building the sky. And here I am, deputy lead rover driver. So that's one of the things I've really liked about NASA is just, they want to see that you have a basic skill set, but it doesn't, a lot of the stuff that we do, you can't learn in school. There is no Mars rover driving degree. We have our own class set that we teach you once you get to JPL, but you can't go and sign up for those classes at school. So in particular, I think however you can prove that you can keep learning and adapting, that's going to be the most important thing.
Super. Wow. Wow. You're right. That you just don't go down to the driver motor vehicle department and say, "Give me my Rover license test."
Mm-hmm.
So it makes total sense. Yeah. The idea of having arts and humanities and law, business, even I can imagine.
Yep. We
Education.
have human resources, we have business offices, all that kind of stuff.
Super, super. Yeah, we like the A and STEAM, add that into STEM here. We like to do artistic things as well. So I like the mission patch example. This is more of a technical question from Isabel. It has to do with what's the electronics on the inside of the rovers and Ingenuity? Are you using computers? Are you using microcontrollers? How do you design, test, build, program them? What are you working on?
Yeah, so we're using computers, but they are old compared to anything that you are running today. And the reason for that is because we're in space where there's a lot more radiation. It gets a lot colder and it gets a lot hotter. They have to survive an environment that your laptop does not. Um, the particular computer type that we most commonly use is called the RAD6K. Um, you could go find the specs. Your cell phone is better than it. Um, you know, um, it's just really cool to see like how much we can do even with these like older computers. We certainly got controllers that help manage the motors for driving and using the robotic arm, turning the camera head, that sort of thing. There's a lot of the robotic aspect and electronics that has to go on there to be able to control all these things remotely. Excuse me. We also have there's a whole dedicated what we call fault protection. So, because we don't have someone watching the telemetry 24/7, that's part of what the engineer's job, looking at all that data coming back of like, is something going wrong? Is something not trending in a good way? And also have the rover be able to recognize that. So occasionally, for example, the rover will start trying to drive over a rock, but the rock will kind of stall the wheel. Like, if we can't quite get enough force to go over it. So the rover will actually detect that and stop itself. So then once the engineers come in the next day, they'll say, oh, this is what happened. Let's back off that rock and continue on. Um, so we have to build the rover to be smart to stop itself. And then, the engineers also have to keep an eye on things.
And doing it all with technology that's a lot older than certainly our smartphone. So we got one more question that came in here, and this probably covers a wider space really than just Mars. Just about how many astronauts are in space right now? Do you know the answer to that question? That might be because
yeah. I actually just saw someone post about this the other day. There are currently 10 astronauts in space, at least according to what I just saw. We have the International Space Station orbiting around, and then I believe the Chinese also have 3 astronauts on their space station right now. So I think the total number of astronauts across any program is 10.
How did I know? No question, but
don't hold me to that. But that's what I just saw like a couple days ago. So
okay, super. Well, congratulations on the 13th flight of Ingenuity. That is a huge accomplishment. I know it's 8 past design, the first stage. So that is super. We do have time for one more question if it pops in. And while our audience is thinking about which question they're going to submit here, first of all, we want to thank you for your time and your sharing your enthusiasm and your experience. I mean, this is super cool. I mean, the fact that you're working with Mars from your living room right now, I can say, that's pretty cool. That's a lot of fun. That's kind of a dream job, I would have to say. But thank you. We want to thank the Office of STEM Engagement through NASA for helping arrange all of this. They've really helped us connect with the rock stars of NASA, yourself included, Keri. So just super. Thank you. And then we have recorded this, so we're going to post this back online so folks can come back and see it. And it looks like we've got one more question here came in. This is a great question. How long have you been working for NASA?
Yes, that's a good question. So I I officially started working in JPL in August 2013. In fact, I started on August 5th, 2013, which makes it really easy to remember as the 1-year landing anniversary for Curiosity. So however long Curiosity's been on Mars, subtract a year, and that's how long I've been working at NASA officially. But as a student, I was working on all these different NASA missions, and I started that in August of 2007. So, I've been involved in NASA missions since 2007, but officially as a NASA person since 2013.
Well, congratulations on that. That's a super career. It's wow, amazing. With that, do you have any final bits of wisdom that you'd like to share with our audience?
Yeah, so I think my favorite piece of advice is don't be afraid to fail. I I failed a math class in college and I'm still here, right? Um, I was not good at calculus. I will just be straight honest. And still somehow I ended up with a math minor. I really don't know how I how I got that. But my general feeling was I didn't want the math class to get in the way of what I wanted to do, so I just kind of persevered. Um, and you know, I certainly have not been perfect at work. I've made mistakes, and the best part is being able to own up to it. Say, okay, I made this mistake. How are we going to make sure that someone else doesn't make the same mistake? Do we have to train people because we found something we just didn't think of before, or better documentation, or put it in our procedures, or something like that. Um, you know, so don't be afraid of failure, because then you get to learn and you get to help others learn. So that's my number one piece of advice.
Oh, that's super, super. Thank you very much. Everybody, thank you very much for joining us today. And do follow us on social media and that. We're going to get that video posted out here probably in the next couple of weeks so we can come back and see Keri again. Again, thank you very much. And everybody have a great afternoon and weekend. Thank you.